Hello student, I am Bishwajit Bhattacharjee, Physics faculty of PAP team. Today we will discuss about the chapter current electricity. It is very important chapter for your board exam as well as NEET exam. So current electricity, we will discuss about the subtopic today about the current, definition of terms related with electric current and Ohm's law. Very basic part of this chapter. Okay, so first we will discuss about the current. What is current? Basically, you know that current means the flow of electrons, right? Flow of electrons, you know that. If this is a conducting wire, if electron flow through this conductor in this direction, then you know that the flow of current is opposite to the direction of flow of electrons, right? So current is basically the flow of electrons. And what is the definition? Basically, the rate of flow of charge through a point in a conductor is called current. Rate of flow of charge. Okay, rate of flow of charge. It is measured by two quantities like instantaneous current, which is equals to dq dt, like instantaneous velocity, average velocity, you know that, class 11. And average current is delta q by delta t, that is total charge flow through the conductor by time interval, right? So if current flow through a conductor in a varying mode, then we can calculate instantaneous current or average current. Instantaneous current means current at an instant, that is called dq dt, and average current means current in a time duration. Okay, current in a time duration, that is average current delta q by delta t. Okay, so say in this numerical, the charge flowing in a conductor varies with time is given q equals to at minus bt square. Then for current, which statement is incorrect? Like there is a 4 statement, like decreases linearly with time, reaches a maximum and then decreases, fall to 0 after time t equals to a by 2b, and changes at a rate of minus 2b. Which one or which are the correct statement? And here q is given, q is equals to at minus bt square. If you find current, you know that instantaneous current, that is dq dt, right? dq dt, that is equals to obviously a minus 2bt, a minus 2bt, that is instantaneous current, right? A minus 2bt. And here at t equals to 0, current is, instantaneous current is a fixed value, that is a. Okay, at t equals to 0, instantaneous current is a. And what is the change of current? Rate of change of current, which is changes at a rate minus 2b. That means di dt is equals to minus 2b. That means rate of change of current is minus 2b, and minus 2b indicates the current decreases, right? Current decreases. So decreases linearly with time, it is right answer, because the rate of change of current is minus 2b. So minus indicates the current decreases, reaches a maximum and then decreases. That is wrong, right? That is wrong. Fall to 0 after time t equals to a by 2b. In which time current is 0? Say this value is 0, t equals to a by 2b. So current 0 after time t equals to 2b, that is also right, right? and changes at a rate of -2b, that is also correct. So these three A, C, D are correct, but B is wrong. Okay. Next question. In a closed circuit, I at an instant of time, that is current at an instant of time in second, is given by I equals to 4 minus 0.08 t. You have to find the number of electrons flowing in 50 seconds through the cross section of the conductor. In previous question, basically there is given Q is a function of time, but here and you have to find the current. So we differentiate the values. So I instantaneous equals to dq by dt. In this case, I is given as a function of time, and you have to find basically the charge. So as I equals to dq dt, so we can write dq equals to I into dt, right? If we find the amount of charge flow through the conductor, then you may calculate the number of electrons flow through the conductor, right? So we have to integrate this function, and limit is 0 to 50, right? 0 to 50, that is 0 to 50. I is the 4 minus 0.08 t dt, right? So if you integrate this value, that is 40 minus 0.08 t squared by 2. Okay, Q equals to. So if you put this value 0 to 50, then it will be 4 into 50, that is 200, right? And 0.08 into t square, that is 8 by 100 into t square means 50 square, 50 into 50, that is 200. 200 by 2, that is 100, right? 100, that means 100 coulomb. The charge flow through the conductor is 100 coulomb. You have to find the number of electrons flow through the conductor, and you know that in previous chapter we already discussed that Q is plus minus Ne. So number of electrons flow through the conductor, basically 100 divided by E, that is 100 divided by 1.6 into 10 to the power minus 19, right? That is the number of electrons flow through the conductor. Okay, is this clear? Okay, next question. In previous question, basically I given as a function of time, but here I is given graphically, right? I versus time graph is given, and you have to find the number of amount of charge flow through the conductor, and you know that dq is equals to amount of charge flow through the conductor is equals to I dt. So I dt means integrating I dt means Q is equals to area of the IT graph, right? IT graph. So what is the value of this area? This is half into length, half into base into height. Base is 30 and height is 20. So this value will be 300 coulomb. Okay, 300 coulomb. So you have to memorize that if the IT graph is given, and if you have to find charge flow through the conductor, then basically area of the IT graph is represent the amount of charge flow through the conductor. Okay, area of the graph. Next we will discuss about the basics, some basics idea of electric current. Okay, current means the flow of electrons. Say there is a conductor like made of iron or copper, like a conductor means like a metal. Okay, so this is a metallic wire, and you know that in case of metallic wire or in case of conducting material, there is number of electrons, free electrons present at that material, and this free electron basically carries the currents, right? So that means there is some free electrons present in this wire, right? Present in this wire, and this electron basically flow through this conductor. If we connect with this conductor through a battery, then current will move, right? Current will move. But in case if we do not connect with this battery, then what will happen? Basically, electrons does not flow. That means electron is at rest. No, basically electrons, these free electrons move randomly. Okay, move randomly. But when we connect with this battery, basically in this conductor, an electric field generate. Okay, an electric field generate in this direction, opposite direction. Okay, opposite direction, an electric field generate, and you know that electric field basically push the charges, right? Gives a force on the charge. And you also know that positive charge always move towards the electric field, and negative charge always move opposite to the electric field. As this electron is negatively charged, so it will move, or it will experience a force opposite to the direction of electric field, right? So these electrons, when we connect with battery, a metallic wire or a conductor connected with a battery, then in the conducting wire there is an electric field generate, right? And this electric field basically gives a force on the free electrons in a certain direction. That may be the direction, obviously this is electron to negatively charged, so electron basically experience a force which is oppositely directed to the electric field. Now what will happen? Basically when current flows, that means electron flow through the conductor, right? Electron flow through the conductor, and when electron flows through the conductor, is this velocity uniform or accelerated? Basically electrons experience a force, so these will be obviously accelerated. But basically what will happen in this conductor, say these are the free electrons, these are the free electrons, and these electron accelerated by this electric field, so this electron move towards this electron and collide with this electron, okay, and instantly its velocity may be 0 or maybe decreases, then it will again accelerated through this electric field, and move towards this electron and again collide with this electron, right? So this is this motion not a uniform motion, uniform velocity motion. Okay, this is basically accelerated motion. And here a term is drift velocity. What is drift velocity? Drift velocity. Basically, drift velocity is a velocity in which electron collide with this electron. Okay? When this electron collide with this electron, then the velocity achieved by this electron is called drift velocity. Okay? Then what is the velocity at that time? Basically, see, this electron collide with this electron collide this electron. In between these two successive collision, the distance is called free path. And average of these distances is called mean free path. What is mean free path? This is the separation between the two successive collision of electrons. Okay, this is the separation of two successive collision between the electrons. Okay, this is mean free path. And there is another term which is called relaxation time. And what is relaxation time? Basically, this is the time required to move an electron by this path. Okay? To move the electron, time required to move an electron by lambda. Okay? This is called relaxation time. That means time gap between the two successive collision. That is called relaxation time. Okay? Then what are the relation between this relaxation time and drift velocity? Say, in this wire, electric field generated is E. Okay? E is the electric field produced in the wire. If potential difference of this battery is V, you know that the electric field, relaxation time denoted by tau. Okay? Electric field generated in the conducting wire, obviously E equals to V by L. You know that if this length is L, then in this wire electric field is equals to V by L. You know that this formula already discussed in electrostatics part 2. Okay, so electric field is equals to V by L, and force on electrons, you know, Q into E. Here Q is E, charge of an electron, into capital E, right? So acceleration will be E by m, right? E by m. Acceleration will be E by m. So drift velocity, you know the equation V equals to U plus AT. Basically, when this electron collide with another electron, then the velocity will be and this velocity is called drift velocity. Velocity will be u is 0 plus a is e by m and t is tau, right? Drift velocity will be em by tau. So drift velocity will be e tau by m. Okay, e tau by m. Very important formula. Drift velocity is equals to em by e tau by m. Then basically drift velocity depends on which factor? Obviously drift velocity depends on electric field. So you can say that electric drift velocity depends on potential difference of the cell. Okay, basically when potential difference increases, electric field inside the conductor also increases. So when electric field increases, drift velocity also increases. Basically drift velocity depends on electric field or potential difference of the battery or potential difference between the two terminals of the conducting wire. And in which factor? Tau, right? Tau. Drift velocity also depend on tau or relaxation time. And in which factor relaxation time basically depends? Basically relaxation time, you know that relaxation time is the time gap between the two successive collision. Time gap between the two successive collision. In which factor this time varies? Basically when temperature of the conductor increases, mind it, temperature of the conductor increases, then vibration of atoms or vibration of the electrons basically increases. You know that, right? So when vibration increases, obviously the number of collisions also increases. That means time gap between the collision obviously decreases, right? So in case of tau, relaxation time depends on basically temperature. Only relaxation time depends on temperature. This is the only factor. Okay, so you have to memorize this. If temperature increases, mind it, if temperature increases, very important point, temperature increases, tau or relaxation time basically decreases. Okay, decreases. So when temperature increases, tau decreases, means drift velocity decreases. So basically drift velocity depends on two factors. Okay, one is potential difference across the terminal of the conductor, and another one means potential difference when potential difference across the terminal of the conductor increases. Obviously electric field is also increases, so drift velocity also increases. And another factor is tau, which is basically depend on temperature. If temperature of the conductor increases, then obviously vibrations of the atoms increases, temperature increases, vibration of the atoms increases, so number of collisions between the electrons also increases. So number of collision increases means time gap between the two successive collision also decreases, right? So temperature increases means tau decreases, and tau decreases means drift velocity decreases. That is very important. Okay, so this is the factor in which drift velocity depends. Then there is a term which is called mobility. Mobility. Mobility basically defined as drift velocity depends on electric field. So mobility basically depends on, mobility defined as amount of drift velocity of a charge by unit electric field produced in the wire. Okay, that means drift velocity by E, that is called mobility, and mobility denoted by mu. Okay, mu. Then what is the value of mobility? Obviously mobility is E by m into tau. Basically mobility depends on the charge particle. Mobility of electron is differed with the mobility of, say, alpha particle. Okay, in each charge particle mobility is different. So basically mobility depends on charge particle, but also depend on tau, which is depend on temperature. Okay, so mobility is the drift velocity per unit electric field. Okay, drift velocity per unit electric field is called mobility, and it is depend on the basically charge particle, like electrons, alpha particle, protons. Different charge particles means different mobility. Okay, that is also important. Then so we basically define various terms here, right? Like mean free path, like relaxation time, like drift velocity, and mobility. And also we discussed about the variation of these terms with other variables, right? So that is very important. Next we will discuss about the current. Okay, so we will discuss basically the motion of electrons through the conductor is the accelerated motion, right? But we can assume that electrons, all the electrons move with same velocity, that is called drift velocity. There is no problem. Okay, so we can assume that electrons moving with the velocity drift velocity, and that is uniform velocity. Okay, say in this cross section, say this cross section is A and this cross section is B, and electrons move in this direction with the velocity of drift velocity. Okay, these electrons move with same velocity, all the electrons move with same velocity, and that is called drift velocity. And after dt time, say electrons move from section A to section B. Okay, section A to B, and this time is dt. So what is the distance between these 2 points? Obviously move with velocity vd, drift velocity. So this distance will be vd into dt, right? If the electrons move with uniform velocity, then velocity into time, that is displacement. So displacement means distance between A and B section separation between the sections A and B, obviously Vd into dt. And say after dt time, this electron arrive at the B section. Okay, arrive at the B section. So before dt time, say an electron situated at this point. Obviously, after dt time, when this electron move from A section to B section, obviously this electron move from this point to this somehow this point, right? That means in dt time, basically in this portion, all the electrons situated in this portion obviously cross the A section, right? In dt time, in this volume, the electrons situated in this volume, in this area, obviously cross A section in dt time, right? We can say that. So here basically say there is some free electrons, let the number of free electrons in unit volume, okay, in unit volume is n. Basically this is called free electron density, okay, free electron density. And free electron density means the number of electrons, free electrons present in unit volume, okay, is called free electron density. Basically, in which factor free electron density depends? Basically material. In case of iron bar, or in case of copper bar, or in case of gold bar, basically number of free electrons are different metal to metal, okay. Obviously in case of copper wire there is basically greater number of free electron density than iron, okay. So which is a good conductor? Basically where n is large, basically this material is very good conductor, okay. Like copper, there is a large amount of free electron density than iron, okay. So say there is number of free electrons present in unit volume is n, okay. Then what is the amount of electrons present in AB section? So number of free electrons present in AB section will be this. What is this volume? Say this area of cross section is A. So volume will be A into distance between AB, that is Vd into dt, A into Vd into dt. This length into area of cross section is the volume of AB section, okay. And in this case, number of free electrons present per unit volume is n. So the total number of free electrons present in this section obviously into n. That means this number of free electrons present in this section, and all the electrons cross this section A, in dt time. So amount of charge flow through the flow through A section in dt time will be dq equals to, this is the number of electrons crossing through the section. Okay, so this value into E, obviously amount of charge flow through this the section, A into Vd into N into dt. Okay, and you know that current is basically dq dt. So dq dt is, oh sorry, this into E. Okay, this into E. So dq dt is current, that will be NEAVD. This is the formula of current. Okay, I equals to NEAVD. Very important formula. This is relation between the current and drift velocity. Okay, I equals to NEAVD. This is the relation. Okay. Okay. Then. Is there any relation between the current and drift velocity? If current flow through a conductor is increases, then what will be the effect of drift velocity? Nothing. Because drift velocity depends on only electric field produced in the conductor and temperature. Okay. So I equals to NA VD. Next, we will discuss already you know that drift velocity basically, what is the formula for drift velocity? We already discussed, that is EEM by into tau, right? And you also know that this is V by L. So drift velocity will be E into V by M into L into tau. So if we put this value in this equation, where I equals to NEA VD, VD means E by M into tau into V by L. Okay. So what is the value of V? V will be equals to, that is E square, right? So V will be equals to M divided by N E square tau into L by A into I. V is equals to M by N E square tau into L by A into I. Okay. If length of a wire or of a conductor is remain constant, area of the cross section is remain constant, and also temperature means which varies with tau, right? Temperature remain constant means tau is constant. You can say that V is directly proportional to I. V is directly proportional to I. That is basically, you know, that is basically Ohm's law, right? Ohm's law. And you also know that V is equals to I into R. So you may write that resistance of the wire, you know that this is resistance of the wire, and resistance of the wire basically M by N E square tau into L by A. And you also know that resistance is equals to rho into L by A, where rho is the resistivity. So what is the value of rho? Rho is resistivity, which is equals to M by N E square tau. This is the formula of resistivity. Very important formula. This is called resistivity. Basically, you know that the unit of voltage potential difference is volt, current is I, resistance is ohm, and resistivity basically ohm meter. Okay, ohm meter, and resistivity is equals to m by n is square tau. M by n is square tau. So basically, in which factor does resistivity depends? Resistivity, we can write that resistivity is equals to m by n is square tau. Here m is constant mass of an electron, E is constant, that is charge of an electron. Then in which factor does the resistivity depends? Basically there is two factors. One is n and another one is tau. What is n? N basically you know that the free electron density. And which factor does this n depends? Basically material. In case of copper wire, in case of iron wire, in case of say golden wire, n varies basically. Material to material, n varies. So basically if n increases means in case of copper wire basically n is greater than the value of iron, right? So when n increases, obviously resistivity of that material decreases. That means resistivity of iron is greater than the resistivity of copper. Why? Because resistivity of iron, resistivity of iron is greater than the value of resistivity of copper. Why? Because n is greater than n in copper is greater than the value of n in iron, right? So in case of copper n is greater, so obviously resistivity decreases. And another factor is tau. If you know that if tau increases, temperature increases, tau basically decreases, right? If temperature increases, tau basically decreases. You know that already we already discussed about this factor in this case, right? In this case, if temperature increases, tau decreases. So temperature increases, when temperature increases, tau decreases. Then what will happen about resistivity? Obviously that is inversely proportional to tau, right? That means tau decreases. Resistivity when tau decreases, resistivity increases. That means with temperature, if temperature increases, tau decreases, so resistivity increases. Okay? Resistivity of the material basically depends on two factors. One is material of the conducting wire, and another one is tau, which is depend on temperature. So in this case tau rho is depends on two factors. One is material and another one is temperature. Okay, is it clear? So these all are very important. Okay, basically dependency of all these terms. Okay, then another one is resistance. In which factor resistance does depends? Basically depends on resistivity. That means resistivity depends on two factor, material and temperature. So resistance is also depends on material and temperature. Also depend on length and area of cross section. If length increases, resistance of the conducting wire increases. If area of cross section increases, resistance of the conducting material decreases. Okay? But mind it, resistivity doesn't depend on the length and area of cross section. Okay? Because resistivity, formula of resistivity is M divided by N is square tau. Clear? We already discussed all the related terms with current electricity. That is mean free path, relaxation time, drift velocity, mobility, free electron density, okay, resistivity, resistance, and also you have to know that resistance 1 by R is called, 1 by resistance is called conductance. Okay, conductance. And 1 by rho is called, 1 by resistivity is called conductivity. Conductivity. These two is also important. Okay, 1 by R is conductance. Basically, what is the resistance? Resistance basically which basically this is the property which can resist the flow of current. That means if resistance increases, current will decrease. Okay, current will decrease. So resistance 1 by R is conductance. That means whenever conductance increases of a conductor, basically current will increase. Okay, and 1 by resistivity is called conductivity. These two terms is also very important. Okay, so this is the interrelation between the various quantities, and also this formula is very important. I equals to NEAVD. I equals to NEAVD, and also you have to know the proof of Ohm's law. Okay, proof of Ohm's law, and that is the formula for resistivity, and that is the formula for resistance. Okay. Next, we will discuss about some numerical problems. Like suppose the drift velocity in a material varies with electric field E as Vd equals to root E. Root E. Then draw Vi graph. Generally, we know that drift velocity basically is equals to E by M into tau. You know that. That means drift velocity directly proportional to E. And when drift velocity directly proportional to E, you know that potential difference is directly proportional to I. So in this case, when Vd is directly proportional to E, then the Vi graph will be a straight line. Okay, Vi graph will be a straight line. And slope of this Vi graph, slope of Vi graph represent resistance. Okay, resistance. So in original case, drift velocity directly proportional to electric field, and if drift velocity directly proportional to electric field, then potential difference is directly proportional to I current. Okay, and in this case, Vi graph obviously a straight line which is passing from the origin. Okay, and slope of this Vi graph represent resistance of the wire. Mind it, that is very important. But here Vd is given directly proportional to root E, not E. Okay, directly proportional to root E. Then what will happen? You know that I equals to NEA Vd, right? And NEA, obviously if you put the value of Vd, basically Vd is here k into root e, তাই তো, right? K into root e, something constant. Vd equals to k into root e. K is constant here, so Vd NEA into k into root e. So you can write I equals to NEA k into root of V by L, because potential difference by length is equals to electric field. So here basically we can write that V is directly proportional to I square. V is directly proportional to I square. Then what will happen? What is the shape of this VI graph? Basically this represents a parabola. So this is the graph for this case only. For this case, this is the VI graph. Okay, but in general case, VD is directly proportional to E, so the graph VI graph will be straight line passing through origin. But in this case, when VD is given directly proportional to root E, then VI graph obviously a parabolic and axis obviously directed towards V, right? Because power of V is 1. Okay. So this is the pattern of VI graph. Okay. Next question. In the following diagram, current and drift velocity at the section A and B. This is section A, drift velocity is VA and current is IA. And in this section, drift velocity is VB and current is IB. Then which one is correct? Basically, basically in this diagram already see there is in the A section cross section area is greater, and in this section cross section is lesser. That means radius of this section is greater. Okay, radius of this section is greater. Then what will happen? Is IA is greater than IB, or VA is greater than VB, or IA is less than IB, VA is less than VB? Which one is correct in this option, from this option? You know that area of cross section I equals to NEAVD, right? I equals to NEAVD. So in this equation, like I is directly proportional to A, but not that. I doesn't depend on area of cross, means in a section of conductor, basically current will be same. Okay, current throughout the conductor will be same. So in this equation, how can we justify this? I is same for all the section. Basically I is same, basically different is A into VD, and A1 into VD1 A1 into VD1 is equals to A2 into VD2. A1 V1 equals to A2 V2. You already read it, right? In class 11, this is called equation of continuity. Okay, equation of continuity, and this equation is also justified in this equation, in this case. Okay, so area of cross section is inversely proportional to drift velocity. Where area of cross section is smaller, obviously drift velocity is large. Okay, so here I1 is IA equals to IB, but VB is greater than VA. And which option is correct? VB is greater than VA, right? Option C is correct. IA equals to IB and VB is greater than VA. Is this okay? So basically I equals to NAVD, this is only one section, so there is no current obviously doesn't varies in these two section, so current remain constant, IA equals to IB, but this in this section as area is decreases, so drift velocity will be increases, so VB is greater than VA. Okay, next question, very interesting question. In the following diagram, resistance will maximum between the faces front and back. This is front side, front and back, or top and bottom. This is top side, top and bottom, and another one left and right. Obviously, left and right. All of the above, obviously, all of the above is not correct. Which option is correct? Front and back, top and bottom, or left and right? Basically, you know that resistance will be maximum. You know that resistance is rho into L by A. That means resistance in the two faces will be maximum where length is maximum, but area of cross section is smaller, right? First case, in front back, R in front back, okay, front back, that will be rho into front back, obviously length is 5 centimeter, length is 5 centimeter, this is the length in between front and back, okay, 5 centimeter, and area, basically front area is this area, right, that is 3 into 4, resistance top bottom, rho into top bottom, in between top bottom, length will be 4 centimeter, and area, obviously area of this top is, this is 3 and this is 5, okay, this is 3 into 5, and what will be the resistance? Left right is rho into left right, obviously length is 3 centimeter, and area is 4 into 5, okay. So resistance will be maximum in this case, that is front and back, in these two between these two surfaces, front and back, resistance will be maximum between these two surfaces, and between these two surfaces, that is left and right, resistance will be minimum, because in between these two surfaces, left and right, length will be taken as 3 centimeter only, that is minimum length, but area of cross section is maximum, right? This area is maximum, because this area will be 4 into 5, okay, 4 into 5, so resistance maximum between the front and back, and resistance minimum between the left and right. Very important question. Okay, another question that is also very important. What is the drift velocity of electrons if current flowing through a copper wire of 1 millimeter diameter is 1 ampere? Okay, 1 ampere current, and diameter of the copper wire is given. You have to find drift velocity. Okay, drift velocity, and you know the relation I equals to N E A V D. obviously area is given, basically diameter is given, so area equals to pi r square. Pi r square means pi into, that is 1 millimeter given diameter, right? 1 millimeter diameter, that means 1 into 10 to the power minus 3, that is meter, by 2, that is radius, whole square. Okay, whole square. So this is pi by 4 into 10 to the power minus 6. Pi by 4 into 10 to the power minus 6, that is area of cross section of the conductor. Okay, area of cross section of the conductor, pi by 4 into 10 to the minus 6, that is area of cross section of the conductor. And value of E is known, right? That is 1.6 into 10 to the minus 19. You have to find drift velocity. So you have to know about the value of N, which is not given, right? N, you know that number of free electrons per unit volume or electron density. Here, assume that each atom contribute one free electron. Okay. And density of the copper is also given 9 gram per cc. Say, if we take 63 grams of copper, 63 grams of copper, obviously 63 grams of copper means 1 mole, means number of atoms is present in this copper, obviously Avogadro's number, that is 6.023 into 10 to the power 23. That means if number of atoms, that means one atoms contribute one free electrons. That means you can assume that 63 grams of copper, basically there is number of free electrons is 6.023 into 10 to the power 23. That is the number of free electrons present in 63 grams of copper. Okay. And what is the volume of this mass of copper? Obviously, this is mass. Volume, you know that m by rho. Rho is the density, m by d. Say m by d. That is, volume is m by d. And m is 63 gram and d is density, that is 9. That means 7 cc. Right? 7 cc. Volume is 7 cc. So N will be, number of free electrons per unit volume will be 6.023 into 10 to the power 23 divided by 7 cc means 7 into 10 to the power minus cubic centimeter. You have to take in meter cube, right? Meter cube. That means 10 to the power minus 9 volume. Okay, minus 9. So you have to calculate the value. You have to put in this equation, N is 6.023 into 10 to the power 23 divided by 7 into 10 to the power minus 9. E is 1.6 into 10 to the power minus 19 and area is pi by 4 into 10 to the power minus 6 and I is 1 ampere is given. I is 1 ampere is given. So you can find the value of drift velocity. Okay. The basically calculation part is tough, but numericals is easy, right? Next one, the VI graph for two conductors is given below. This is VI graph of two conductor. One conductor is A and another conductor is B, and VI graph is given. Okay, VI graph is given. You know that already we discussed the graph is a straight line, okay, and passing through origin in case of Ohm's law, right? And you also know that in this case, slope is the resistance. Slope is the resistance. So what is the value of resistance of A? Resistance of A will be tan 30. Okay. And what is the value of resistance B? RB will be tan 60. Because B makes an angle with x-axis is 60 degree, right? B makes an angle with x-axis is 60 degree. So resistance of A will be tan 30 and resistance of B will be tan 60. So what is the ratio between RA and RB? RA divided by RB. This will be tan 30 by tan 60. So resistance of B will be greater, right? That will be 1 by 3. So find the ratio of the resistances tan 30 by tan 60. If conductors are identical, identical means length, area of cross section, material all are same, then which one has greater resistance, greater temperature? You know that if temperature increases, resistivity of the conductor also increases, and resistivity increases, resistance also increases, because you know that R equals to rho into L by A. So if temperature increases, resistivity increases, so resistance also increases. So resistance is higher, obviously, in case of B. In case of B, resistance is higher. So the temperature of the conductor B will be greater than the temperature of the conductor of A. Okay, that means we can write that temperature of the conductor of B will be greater than the temperature of the conductor of A, because resistance of B is higher than the resistance of A. And next one, if conductors have same dimension, means length and area of cross section is same. One made by copper and another made by iron. Which one made by copper? That means materials of A and B is different. You know that in case of material differs, then resistivity also differ. And in these two cases, copper and iron, you know that resistivity of copper obviously less than the resistivity of iron, right? Resistivity of copper is less than the resistivity of iron, because number of free electrons in the copper is larger than the number of free electrons present in iron. Okay, you know that resistivity, you know the formula of resistivity. So resistivity basically depends on the number of free electrons per unit volume or electron density, and electron density in copper obviously lesser than the electron density is greater than the iron. So if the number of free electrons or electron density is higher than the is higher in copper than the iron, so resistivity obviously decreases, right? Resistivity decreases. So if resistivity decreases, resistance also decreases. That means resistance is greater is B. So obviously material of B, material of B is iron. Material of B is iron, and A is copper. Okay, A is copper, because resistance of copper is less than the resistance of the wire B, right? So that's all for today's class. Next, we'll discuss about the combination of resistances in next class. Okay, that's all for this class. Thank you.